Hello everyone. In this video, we shall discuss a machine tool which is called a standard deviation. What do you mean by a standard deviation? Standard deviation is a number that describes how spread out the values are. This can also be interpreted in this form, wherein how the values are closer to the mean value or the average value. A low standard deviation means that most of the numbers are close to the mean value or the average value. Whereas a high standard deviation means the values are spread out over a wider range. We shall discuss the same thing with the help of an example. Let me take an example of the speed of seven different cars, wherein the speed of seven different cars are listed like 86, 87, 88, 86, 87, 85, and 86. So here, what is the standard deviation? The standard deviation here is zero point 0.9. How? Let me explain you. The values are 86, 87, 88, 86, 87, 85, and 86. Wherein the average of these values or the mean of these values is 86.4. So 86.4 is a mean value. Now let us take every value. What is the difference between that individual value with the mean value? Let us calculate. Say 86. The difference between mean value and 86 is 0.4. 87. The difference is 0.6. 88. The difference is 1.6. 86 once again 0.4. 87 once again it is 0.6. 85 is in the negative direction minus 1.4. 86 is once again 0.6. So what is the meaning? Except for two values 88 and 85, most of the values are within the range of 0.9, zero point 0.4, zero point 0.6, 0.4, zero point 0.6, except for 1.4 and minus 1.4. Only for two values it is more than that, but most of the values are within the range of 0.9. That is what the standard deviation is 0.9. So this is a theoretical part of the standard deviation. Means what is the deviation of the values from the mean value? That is the standard deviation. That means what is the deviation of the values in this above example from 86.4? So we'll take another example where the speed is 32, the different type of example. Speed is 32, 111, 138, 28, 59, 77 and 97, for which the standard deviation is 37.85. The range is wide here. Compared to the previous value, in this previous case, the deviation is 0.9. But in this case, the deviation is 37.85. Means the values of the most of the values are ranging at a distance of 37.85 from its mean value, which is 77.4. How do you find out the mean? Take the average of it. 32 plus 111 plus 138 plus 28 plus 59 plus 77 plus 97 by 1, 2, 3, 4, 5, 6, 7. So that comes to 77.4, but here the difference is more. So that means it is a high standard deviation, not a low standard deviation. It is a high standard deviation. So, as you can see, a higher standard deviation is seen here, which means the values are spread out over a wider range. In the previous case, the values are spread out over a very small range. The difference is only 0.9. But in this case, the values are spread out over a wider range with the difference of 37.85. So that's what it's called. It's a higher range of standard deviation is high here. So it's a theory about it. Now, in Python, a module is used for calculating standard deviation is numpy. Basically, numpy is an abbreviation for number Python, which is most of the time used for numerical calculations. A module which is famous for various numerical calculations. Here in this case, a function called std is used to find out the standard deviation. Very simple it is. You define a list, but before that, import numpy, define a list. In this example, it is defined as a speed 86, 87, 88, 86, 87, 85, 86. Then calculate numpy.std of speed. That will give you the standard deviation of the above list stored in a variable called x. You print that x, that will give you the standard deviation. See, it is 0.90350,790. It's a big number. You can round it up to 0.90. Wherein here I will change the value to find out a different example. See, I will give a different value. For example, let us say 25, comma, say 102, comma, say 250, comma, say 55, comma, say 89. So you can give your value. Now let us see what is a deviation. Whether a very small deviation you will observe or a large deviation you will observe. The answer turns out to be 77.70 because the mean value of this being a value wherein the values are ranging at a farther distance, at a higher distance. So, in this example, the standard deviation is 77.7 because the values are having a different range. Whereas I'll take another set of value, wherein I will take say 10, comma 9, comma 8, comma 9, comma 11, comma 15. See, very closed values. So these are all the values which are very closed. So here deviation between the mean value is somewhere around 2.28. So it all depends upon the selection of values. How much your value is deviating from the mean value. So very simple. You use a function called std function, which is defined in a method called numpy. Import numpy, define a list, use a function called x is equal to numpy dot std of this list, print it. That will give you the standard deviation. So very simple function is used here to find out the standard deviation. That is a std function which is used over here. So for a different example it is given over here, standard deviation. Next is a variance. Now variance is another number that indicates how spread out the values are. Now, what is the meaning of it? It's almost the same meaning of your standard deviation. It's another number that indicates how spread out the values are. What is standard deviation? The definition of standard deviation says here, number that describes how spread out the values are. Standard deviation also is a number that describes how spread out the values are. At the same time, variance also says it is a number which indicates how spread out the values are. In fact, what is a variance? What is a variance? It is nothing but square of the standard deviation. Or if you take the square root of the variance, you're getting the standard deviation. Both are having a same meaning. It's a deviation from the actual value. So it's a spread out value from a mean value. But the difference what you observe between standard deviation and the variance is the standard deviation is the square root of the variance. Or otherwise, it is the square of the standard deviation. Or even otherwise, you can say it is a multiplication of the standard deviation by itself. So suppose if we get, what do you mean by variance? Variance is the value from which how the values are spread out. It is the standard deviation which is multiplied to itself, or it is the square of the standard deviation. Now, how do you do that? You find the mean. So there are values which are given, 32 plus 111 plus 138 plus 28 plus 59 plus 77 plus 97. You divide it by 7. You get the mean, which is 77.4. For every value, you find out the difference. What is the difference between 77.4 to 32? It is minus 45.4. What is the next value? Difference between next value with the mean, 111 minus 77.4. It comes to plus 33.6. Next is 138 minus 77.4. It comes to be plus 60.6. Then 28 minus 77.4, it comes to be minus 49.4. 59 minus 77.4, it comes to be minus 18.4. 77 minus 77.4, it comes to be minus 0.4. 97 minus 77.4, it is 19.6. It is a deviation. It is the individual deviation from the mean value. So the values, whatever you see over here, 32, 111, 138, 28, 59, 77, 97, like this. So it is nothing but the individual deviation is whatever you see over here. Now what you do is, for each difference, find the square of it. Then you add those square and divide by 7, or you take the average of the square. It comes to be 1432.2, which is nothing but the square of 77.4. If you take 77.4 into 77.4, you are getting 1432.2. That's the value. So, description given over here is to find out the variance. How is it done? Initially, you find the mean value, then you find the individual difference, that's the deviation, then you take the square of each deviation, take the average of it, that is the variance. So, how do you calculate the variance? First, find out the average of the value. Then take the individual difference as shown over here. Take the square of each difference. Then take the average of the square of the each individual difference. You will get the variance, which can be done using a very simple formula called a function called VAR in NumPy. Import NumPy, you define a speed, then take x is equal to numpy dot var of the speed, print x. You get the variance. How did you get the standard value? Numpy dot std. See, okay, I'll modify this program. Say you got the variance of this particular values, set of values for the speed. I will take y is equal to, say, numpy dot standard deviation of the speed, then I will print y and I will run. What do I get? Let me see. So I'm getting two values. First value being the variance, second value being the standard deviation. So this is the difference between variance as well as standard deviation. Okay, see, it became 37.85. Just now what we have seen over here in this example. So numpy.std gives the standard deviation, numpy.var gives the variance of it. So that is a discussion what we had for standard deviation as well as variance. Next, let us see what is the meaning of percentile. All these are related to statistical functions. Percentiles are used in statistics to give a number that describes the value that a given percent of values are lower than. It is used in statistics to give you a number which describes the value that a given percent of the value are lower than. We'll take an example. So age is given. Age of some people are given, say 5, 31, 43, 48, 50, 41, 7, 11, 15, 39, 80, 82, 32, 2, 8, 6, 25, 36, 27, 61, 31. Now, what is the 75 percentile? It is 43. What is the meaning of percentile? What is the meaning of this question? What is the 75 percentile of ages? The meaning here is, what is the 75% of the people in this age group? That means you find 75% of this particular age people are below 85, sorry, below 43 years group. That is a percentile. Normally, this is one very important calculation, sir, very, very important requirement. For example, when you are targeting a particular domain, say you're coming out with one particular product which is more capturing the youth. So the people who are below 25 years. So under that circumstances, before you try to sell out your product in that particular domain, you'd like to know what is the population. See, if you are very sure that, see, you have a condition that my product should be sold out to a domain wherein at least 75 percentage of the people should be below 25 years. If you have that condition, what you do is you take the samples. What samples? Ages of all the people who are in the area wherein you would like to promote your product. Then out of which you find out what is the 75 percentage of the population. So if you say that, okay, 75 percentage of the population is below 25 years, you will be happy. Yes, this particular domain is a place wherein I can sell my product. Specific example I will give you. Say that you are a fisherman, you want to sell fishes. You have a vehicle of your own to sell the fishes. Now, I will give you two different locations wherein you can sell the fishes. First location is a location wherein the entire location may be having, say, 400 people or 500 people who are purely vegetarian. Will you be able to sell your fishes? You cannot. Whereas you have one more section wherein same population, 500 population is there, wherein 75% of the people are non-vegetarians. Wherein you can definitely sell your fish. So, one example is that. Another example, say you are coming out with one new type of dress, wherein more the people under age 25 will be more attracted towards that dress. So now you would like to identify the location wherein you will get a good business to sell out your shirts, sell out your dress. So what you do is you send some people to see the area, and he comes with the data that there are 500 people and every person is of this particular age. Then you use this percentile concept there to find out what is the target domain. So, what is your target domain? Your target domain is the people who are below 25 years. Suppose if your 75% of the total population is, say, out of 500, if you get 400, yes, you are happy. You say that, yes, I can sell my product. But how do you come to know that 400 people out of 500 are below 25 years? Percentile. So, you take the percentile of the particular age group. And if you get, say, percentile, say 73%, 75%, or you say 50%, or you say 60%, it's all your wish. How much percentage you want? Say, total, say, if you say 60%, you may get more number. Whereas if you say 80%, so if you say 80%, then you may get more number. If you say 60% or 50%, you may get less person, less people. So, calculation of the percentile is, the use of percentile is then used, or there it's used, wherein you are interested more towards the product sales. One example as I give you. So to do so, you're using a function from a method called numpy, that is called percentile. Very simple it is. Import numpy, define the ages of the entire population. So x is equal to numpy dot percentile, ages, comma 75, print x. So you used three functions. STD function to find the standard value, variance var function to find out the variance of it, percentile, you're using numpy dot percentile, ages, comma 75. 75 is a benchmark. Your benchmark. You can select 60 also, you can select 50 also. It is all up to you. So what is the benchmark you expect? So the more you put benchmark, the less you will get the people. The less you put the benchmark, the more people you will get. So this is how you calculate the percentile of it. So one more is given. What is the age that 90% of the people are younger than? Right? So to which your answer will be 61 people in this example. So they are all younger. So your target is 90%, of course. Suppose if I make it, say, younger means it should be below 30. I cannot say that 90 people are younger. So when you take 30, you get only 15 people. So a person who is targeting 30 years or less than 30 years, he may find that only 15% are available in this particular domain. Then he has to take a decision whether to sell the product or to go or not. Whereas if he says, okay, my product is acceptable by people who are below 60 years, then he will give percentile and he says 36% of the people of the total area are satisfying my condition. Yes, I may go to sell the products. That is percentile. So we have seen the mean, mode, variance, standard deviation, variance, then percentile.